Welcome back to The Explainer. I am so absolutely thrilled to have you here today. Okay, let's jump right into this because we've got a lot of ground to cover. Today, we are taking on one of the most notoriously tricky, yet honestly incredibly rewarding topics in the Cambridge AS and A-Level Mathematics 9709 syllabus. We're talking about formulating differential equations from rates of change. Now listen, I want you to completely change how you view these word problems right from the start. I need you to stop looking at them as just math equations dumped onto a page. Instead, I want you to think of this whole process as an archaeological dig. When you first glance at one of these questions, it usually just looks like a massive, intimidating block of confusing text. It's totally covered in dirt. But hidden right beneath the surface of those paragraphs are tiny, brilliant clues. Layer by layer, we are going to brush away the distraction, extract the precise mathematical relationships, and reveal the perfect answer underneath. We're going to become strategic excavators of mathematics today, extracting exactly what those examiners want to see. And you might be wondering, why are we spending an entire explainer focusing on this one highly specific topic? Well, the answer is 15%. That is approximately how much this single topic, formulating differential equations, accounts for in the total marks for paper 2. Just pause and think about that for a second. 15% is not just a passing grade. It is very often the deciding factor that bumps you up an entire letter grade or, hey, even 2. You absolutely cannot afford to skip this, and you definitely cannot afford to guess your way through it. The stakes are massive here. And by the way, while we're heavily focused on the 9709 strategy today, let me tell you this exact skill of mathematical translation is absolutely vital across the board. Whether you're tackling syllabus codes like 0580, 0606, 4024, 4037, 4040, or even jumping into further math with 9231, the core logic of reading a context and building an equation doesn't change. Mastering this one technique is quite literally the highest return on investment you can get for your study time. So, to truly understand how to win those marks, we first need to take a hard look at how students throw them away. Let's look at two totally different but equally flawed approaches. Take Alex over on the left. Alex is incredibly smart, knows literally all the calculus formulas by heart, but Alex's approach is to just overload the page with raw math facts. There's zero analysis, no definitions, just a massive brain dump of complex algebra, hoping the examiner will somehow hunt through it all and find the right answer. Spoiler alert, the examiner won't. It just ends up being a sea of red ink. Now on the right, we have Sam. Sam's problem is different. Sam rushes the problem, spots a keyword like volume, immediately writes down an equation, and completely misses the specific command word requirements of the context. Sam didn't define the variables and didn't even read that the rate was inversely proportional rather than directly proportional. Both of these students lose super easy marks, not because they are bad at math, but because they have absolutely zero strategy. We are going to fix that. To make sure you never fall into those same traps, here is our examiner's playbook for today's explainer. Number 1, core principles and the 15% challenge. Number 2, the technical methodology. Number 3, an interactive workshop. And finally, number 4, examiner warnings and strategy. Let's get into it. Section 1, core principles and the 15% challenge. Right, so the absolutely crucial point here is integration. And no, actually, scratch that. I don't just mean integral calculus. I mean integrating your knowledge. Look at this insight directly from the Cambridge Principal Examiner reports. It explicitly states that candidates who reference cross-topic connections achieve significantly higher marks. So what does that actually mean for you when you're sitting in the exam hall? It means when you're formulating a differential equation about, say, the volume of a sphere expanding, you can't just operate in a vacuum. You need to connect your knowledge of geometry, like knowing the exact formula for the volume and surface area of a sphere, with the chain rule from differentiation, and then apply it to the specific rate of change given in the text. It's like a giant puzzle. You are hitting multiple cognitive domains all at once: knowledge, application, and critical analysis. The examiners are practically begging you to show off your holistic math skills here. To consistently show off those skills, you really need a rock-solid structure. And that brings us to the Peel framework. Now, you might have used this in English or history essays, but it is an absolute superpower in Cambridge mathematics. Point, evidence, explanation, link. In our context, here's how it works. Point, you define your variables precisely. Evidence, you state the mathematical rate given in the prompt. Explanation, you introduce your constant of proportionality. And link, you combine them all into your final beautifully formulated differential equation. Having a structured methodology like Peel turns a totally chaotic thought process into a laser-focused mark-winning machine. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2. The technical methodology. This is where we turn theory into practice. So how do we absolutely guarantee we get those method marks every single time? We use this strict 5-step procedural framework. Let's walk through it together. Step 1. Deconstruct the question. Read it twice. Highlight those command words. Treat it like a mission briefing. Step 2. Extract the relevant data. Pull out the variables. Is it volume, radius, time? Get them out of the text and onto your paper. Step 3. Select your analytical framework. Are things directly proportional or inversely proportional? Do you need the chain rule here? Decide before you write. Step 4. Execute with clear notation. This is huge. Write dv/dt, not just a messy v prime that looks like a smudge. Step 5. Present with correct terminology. Make sure you explicitly define what every single letter means. By systematically following these 5 steps, you literally turn an abstract, anxiety-inducing paragraph into a foolproof, simple checklist. It takes all the stress right out of the equation.
And as you'll see right here, this is exactly what the transformation looks like in reality. Over on the left is your standard average answer. The student just dives straight into the equations. dv over dt equals 5x. There are no definitions. The formatting is totally messy. Now, it might technically lead to the right numbers eventually, but it completely bleeds method marks along the way. On the right, look at the top scoring answer. Just look at the beautiful presentation. Let v be volume. Let t be time in seconds. Let k be a positive constant. The terms are defined, the format is razor sharp, and the steps are cleanly annotated. The examiner sees this and instantly knows they are dealing with an A-star candidate. The red marks completely transform into green check marks. It's a game changer. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 3, the interactive workshop. It's time to test your practical application. Let's see what you've got.
All right, here is challenge 1. We have a data scan challenge. Imagine a 60-second timer is ticking down right now. We have a spherical balloon expanding, and the data tells us the rate of change of its volume is proportional to its radius. I want you to mentally execute step 2 of our framework. Extract that core trend. What is the analytical framework here? Think about it. You have the volume of a sphere changing over time. You know the rate of volume change relates directly to the radius. Your brain should immediately be firing off dv dt and pulling up the formula for the volume of a sphere. V equals 4/3 pi r cubed. This is the archaeological dig in action, guys. You are brushing away the text and finding the pure golden math underneath. Okay, you did great on that one. Let's step it up a notch. Challenge 2. I want you to find the flaw in this statement. The rate of change of volume is proportional to the radius, therefore dv over dt equals r. Look closely. What has this hypothetical student done wrong? Did you spot it? It's sneaky, but it's fatal. The student translated the words proportional to as an equal sign without adding the constant of proportionality. The biggest, most heartbreaking mistake you can possibly make in these exams is forgetting your constant k. It absolutely must be dv over dt equals k times r. If you write dv over dt equals r, you have mathematically stated that the rate of change is exactly equal to the radius, which is an entirely different concept and completely wrong. That one single missing letter, k, literally destroys the entire rest of the 15-mark question. Let's move on to challenge 3, the speed challenge. I want you to imagine you have exactly 30 seconds left on the exam clock. Mentally draft the perfect peel paragraph for that balloon problem we just looked at. Ready? Go. Point. Let v be the volume of the sphere, r be the radius, and t be time. Evidence. We are given that the rate of increase of volume is proportional to the radius. Explanation. Therefore, we introduce a positive constant of proportionality, k. Link. This gives the differential equation dv dt equals kr. Boom. Perfect method marks, perfect presentation, zero room for the examiner to deduct absolutely anything. That is exactly how a pro handles it under pressure.
Section 4, examiner warnings and strategy. Let's talk about how to protect those marks. Listen up, because these are the top 3 mistakes pulled directly from the examiner's desk. Number 1, using the wrong approach for the wrong context. This usually means applying a direct proportion formula when the text explicitly says inversely proportional. It comes down to rushing and panic. Number 2, forgetting to check format and presentation. just writing a messy jumble of algebra with no clear steps. Remember, if the examiner can't easily follow your logic, you lose method marks, even if your final answer is technically correct. Number 3, providing answers that are not specific to the context given. If the question is about water draining from a conical tank and your final equation somehow implies the tank is growing infinitely larger, you've completely failed the context check. Avoiding these 3 massive traps is non-negotiable if you want top-tier marks.
I really want to hammer this point home with this authoritative quote straight from the Cambridge Principal Examiner report. They say, candidates consistently confuse key terminology, always define terms before using them in extended responses. Guys, this isn't just me giving you a friendly suggestion. This is the head examiner telling you exactly, word for word, how to get their marks. When you introduce a variable like x or h or k out of thin air, you absolutely must state what it represents. Just write, let h be the height of the liquid. It takes 3 seconds to write, but it proves your mathematical maturity and locks in your points.
So to achieve what we call evaluative mastery, you need to follow this ultimate success blueprint. It's essentially a continuous loop of good habits. Identify the given information right off the bat. Break the complex problem into logical, bite-sized steps so you don't get overwhelmed. Solve systematically using clear, undeniable notation. Then check for reasonableness. Does a negative rate of change make sense if the balloon is expanding? No, so you catch your own error right then and there. And finally, make justified recommendations or conclusions based on your final equation. Top-scoring candidates don't just calculate blindly, they elevate their work to the level of critical analysis.
And honestly, the proof is completely in the results. Students who consistently practice with these exact strategies, deconstructing the text, defining their variables, checking for reasonableness, see an average improvement of 2 full grade boundaries. Let that sink in. That is literally the difference between sitting at a C and walking away with an A. But you only get there by actively practicing this system day in and day out. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
As we wrap up today's explainer, I want to leave you with a provocative question to really test your new mindset. When tackling your next rate of change problem, how will you evaluate your differential equation to prove its reasonableness? Are you going to check the signs? Are you going to test extreme values to see if the math holds up? Think deeply about it. Start treating these exam questions like an archaeological dig. Apply the Peel framework relentlessly and go get those marks. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.